GraphAware helps organizations gain competitive edge through the application of graph technologies, and we've been doing this for the last 8 years. Today we'll talk about one of our products called GraphAware Hume, which is a graph-powered insights engine running on top of Neo4j. The reason we decided to build Hume is that as we're gaining experience through consulting and helping people use graph technologies, we realized three things. The first one is that there is structure in so-called unstructured data. And the way we realized that is we were asked to build a recommendation engine, the input to which was free text, people, life stories, unstructured CVs if you wish. And that's where we started experimenting with natural language processing and realized that the output of that can be modeled as a graph. So we built the first version of the GraphAware natural language processing plugins, which were open source, posted on GitHub, and they were running as an extension to Neo4j. We started blogging about this and writing articles, speaking at conferences, and this approach started gaining some traction, and it started getting us real-life projects like the European Space Agency knowledge graph of their satellite ecosystem. The second thing we realized is that graphs and machine learning are a natural fit. There are many reasons for this. One of them is that graphs provide context quite naturally. The second one is that graphs enable explainability of machine learning and AI solutions. And there are many, many other reasons, which we will not go into today. So if you're more interested in this topic, I recommend you pick up a copy of this book called Graph-Powered Machine Learning, which was written by our chief scientist, Dr. Alessandro Negro, and it is being printed as I'm recording this video. The third reason we decided to build Hume is that we kept asking ourselves this question: where is the knowledge? As we're watching people use dashboards and decode KPIs to try and find some insights into their data. We strongly believe that knowledge graph as a data structure and as a concept is the best way to represent siloed, disconnected, heterogeneous data, connect them, and gain actionable insights. Let's talk about GraphAware Hume. It is a graph-powered insights engine, at the center of which is the knowledge graph, a collaborative knowledge graph. This is backed and powered by Neo4j, the most popular graph database, and Hume provides on the left side ability for people to ingest data, structured and unstructured, from multiple different data sources. This is provided by a component called Hume Orchestra. It then provides the ability to run certain kinds of machine learning on top of this data, either in the graph or as it's getting into the graph. So natural language processing is one example where Hume is able to extract entities, relationships. It's able to extract key phrases and keywords and write the results of the natural language processing back to the graph. In the enrichment piece, Hume is able to query external sources of knowledge, bring external ontologies, and by external, we mean truly external, as in public or outside of your organization, as well as external to the actual knowledge graph, such as internal private ontologies that you already have. Other kinds of machine learning are supported on top of this graph, especially in combination with Neo4j's Graph Data Science library, with which Hume integrates natively. Ultimately, this solution, this platform, delivers insights to end users and to other applications through APIs and through a very powerful graph visualization library and graph visualization framework. So Hume is a graph-powered insights engine. It's an ecosystem because it is very flexible and pluggable. So your own machine learning models, your own components you already have are easily plugged in, and it allows you to collect, organize, discover, and analyze data, and it is built upon the combined power of collaborative knowledge graph and machine learning. Hume helps organizations to integrate siloed, disconnected, heterogeneous data from multiple different data sources into easy to understand knowledge graphs. This integration is configured and coordinated by Hume Orchestra, which is a powerful workflow engine based on Apache Camel, and its components such as data sources and data sinks and all transformations and machine learning components work together in harmony to deliver all of Hume functionalities. Ultimately, Hume enables augmented intelligence through person-to-person and person-to-machine collaboration. People, users, data scientists, analysts, data-savvy business users can contextualize, analyze, understand, and most importantly, act upon vast amounts of information using the latest advances in natural language processing, graph analytics, graph data science, and machine learning. To summarize, Hume sits between the graph and your end users. It brings analysts, data scientists, and other types of users full power of graph data science, graph queries, and graph algorithms. With that, we will transition to a demonstration of Hume's capabilities. Hume is a web application. So I'm going to log in to this application, and at the center of this application is a knowledge graph, or I should say multiple knowledge graphs. Each knowledge graph you can think of as a project. It's a separate sandbox for all the work you're going to be performing within Hume. I'm going to go to my favorite knowledge graph here called Murder Mystery, which is here for demonstration purposes, fake data, and we will explore this a little bit. First of all, Hume is based on the concept of a schema. So we know many graph databases, and Neo4j specifically is a schema flexible database, but Hume itself has a schema which you as a user will define, and you will choose what types of nodes, what types of relationships, and what kinds of properties these things will have. And for each of those nodes and relationships, you define what attributes they have, what types they are, whether they're primary key, whether they should be full text searchable, potentially whether it's a list or an array of values rather than a single value. At this point, the schema is not connected to the Neo4j database. It is just a concept in Hume that guides other functionality like searching, autocomplete, guides navigation through the graph, and other pieces of functionality. Within the schema section, we are able to manage indexes in Neo4j. So this gives you a useful overview of all the properties and attributes that are primary keys and that should be full text searchable. And with a single click, you can apply these indexes to a selected graph database. The schema itself can have more attributes, more nodes and relationships than your Neo4j database will have. And this is in the case where Hume computes some of these things for you. So we call them sometimes virtual or computed relationships and attributes. Or it can have fewer types of nodes, relationships, and attributes, in which case Hume will not surface everything from your Neo4j database. It will simply show what you have defined in your schema. Hume then has a concept of perspectives, which are views of the schema, and perspective is what ties the schema to a concrete Neo4j database. So in this case, we have a perspective called Murder Mystery, and we are tying it to the Murder Mystery database. In each perspective, you can choose what's going to be visible on the node level, on the relationship level, as well as on property level. So certain kinds of properties, if you wanted to hide people's names, you could do that just by clicking here. This is useful for applying one level of security. When, for example, there's a junior analyst, you don't want to show everything, you will create a perspective, hide the things you don't want to show to the junior analyst, and then make sure that the junior analyst only has access to that perspective, which is possible using Hume's role-based access control, which we're not going to go into today, but I will just say it is extensive and fully featured role-based access control that protects all kinds of resources in Hume, starting with knowledge graphs, perspectives, workflows in Orchestra, and all kinds of other things. This perspective and this schema that's underlying the perspective is a bit of a mix of things just to demonstrate all kinds of Hume functionalities. So don't read too much into what these things mean. We'll be using mainly people and Facebook events. Maybe we'll look at a few earthquakes. Hume ships with Orchestra, which is a workflow engine. And we will not spend too much time today on Orchestra, but we will show you what it looks like. So in Orchestra, you will build these workflows, and each workflow has a task. It takes data from a source and ships the data basically from point to point between all these boxes. And each box either transforms the data or enriches the data. And the ultimate goal is that the data should be written to the Neo4j database or beyond Neo4j database. Of course, we have other kinds of data syncs. So you could, for example, carry on and write the data to, let's say, Elasticsearch for some faceted or very complicated or complex search. Hume Orchestra can read from various data sources, including RSS feeds, all kinds of queues, file systems, cloud file systems, Neo4j itself, of course, JDBC compliant data sources, your relational databases. And of course, it's relatively easy for us to build new components if there is something missing here. Hume also ships with a number of machine learning components. We call them skills. And these include relationship extraction, keyword extraction, PDF parsing, all kinds of embeddings and vector-based machine learning tasks, extracting named entities such as people, location, organizations, as well as what we call generic HTTP enricher, which allows the workflow to call any endpoint you may already have and enrich the data that way. There are a bunch of other features which I'm not going to go into, and we'll move on to visualizations. Hume is a very powerful visualization tool. It is, we believe, the best visualization tool on the market. And you can create a number of visualizations. Each visualization is backed by a perspective. And the ultimate goal of a visualization is for somebody like a data analyst or a data scientist to go in and perform their analysis. So what we're going to look at is a demo visualization. And the first thing we will see is our schema again, this time with the counts of nodes and relationships that we have in the actual Neo4j database that backs the perspective which we're using for this visualization. You can do all the things you would expect from a graph visualization tool. So simply, if you double click here, we'll bring 100 people onto the canvas, and you're able to do all kinds of selections. So we can select potentially here, we'll select all the other nodes, we'll delete them, start with this one, and you would expect to be able to double click and expand everything, or you'd be able to expand selectively certain kinds of relationships for this person. There are other options we will go into later. So if I double click here just to show, all the immediate neighbors are shown, but this is probably a non-impressive feature. So we'll talk about Hume actions. Hume actions are a mechanism to allow people to explore the graph and to run investigations and analyses without writing Cypher queries. And the way that's done is that Hume actions are actually pre-built, pre-canned Cypher queries. So somebody like a power user or an Neo4j expert or somebody from GraphAware will configure these actions for end users. And let's look at a simple one, which is called expand to hops. The scope of the action is local, which means we actually have to select a node or a relationship to be able to run the action. The return type is graph, meaning that the data, when it's returned, will be rendered on the canvas that we were looking at just a minute ago. And you can specify a few other things, such as what types of nodes and relationships this action will be applicable to. You specify the Cypher query that will be executed when you run the action, and you will be able also to pass in some parameters that the user can input. In this case, we have no input parameters. So we're gonna test this out. This should expand, and I'm gonna search for somebody who I know has more than one hop away, just to show you what that looks like. So if I'm gonna right click and then run this action called expand to hops, immediately we get 2 hops away. Hume, of course, has all kinds of layouts here. We're looking at the force layout. There's a hierarchy layout, and there are all kinds of other layouts as you would expect in visualization tools. I'm going to go back to the force one. The other thing we want to briefly discuss is the other return types of actions. Besides returning graphs, actions can return charts, line charts, bar charts, all kinds of heat maps. They can return tables as well. So just a simple table with rows and columns that you can download and export to CSV. There's also some special types of actions. And so I'll show you two. One type of action is special because it returns something called preview. So rather than, let me show you, we're going to be looking at finding paths between two nodes, and we're going to be using some APOC algorithms. We're going to be this time taking some user inputs, but the important thing is that the return type here is preview, which means we're going to let the user preview the results before adding them to the canvas. And the whole point of this is not to clutter the canvas. So a lot of the graph visualization tools have the issue of the user doing something and then suddenly being overwhelmed with too much data on the canvas. So we're trying to prevent that with a number of features, some of which you will see today. And this is the first one. Also notice the scope of this action is multi-selection, whereas previously it was local. There are global actions as well, which you can run globally on the whole graph without selecting anything, but in multi-selection, you have to select at least two nodes. So let's look at two people. I'm gonna find Ninotna and again our favorite Brian guy, and we're gonna run this action where we're gonna try to find paths between them. And we're gonna say, and here is an example where actions can take user input. We will say we want maximum 5 hops, minimum 1, and the limit should be 1000. Now this action potentially can return a lot of data. So in the preview, if I hit submit, we will see all the paths, and there's 53 of them. And what we can do is, sift through them one by one, which is probably not very useful because that could be a lot of steps. But this screen gives you some ability to filter these to be able to select the ones that are interesting. So for example, there's a grouping strategy called all nodes are equal. That brings the total count of paths to 28, so about half. Why is that? Well, because this one, very first one we're looking at, for example, in Neo4j, this is two paths between the end nodes, because there's two exchange relationships. So one path goes through this one path goes through this one. The other type of grouping is all classes are equal. So here we have three results. One kind where all the paths go through either people or Facebook events. The second one where they go through license and people. And the third one where they go through just people. And maybe that's what I want. There are other types of filtering where you can exclude certain kinds of relationships or classes. I will leave that for now. I can select here, add this to the canvas. I only have what I wanted, and I can continue my investigation from here. Now let's look at some of the other things that Hume provides with respect to visualization. So the very first thing we forgot to mention is here. Of course, you can see the properties or attributes of each node, and we can search through them, we can sort them, we can lazy load them if they're too big. We can make sure that they're only loaded on demand. We can also style, and there's number of ways how you can style these things. So for example, here I can very easily add a new rule that says I'm going to add a badge to a person if the attribute is thread is equal to true, and I'm going to make it red and I'm going to make it animated. And of course we can then save this style and just call it demo style, and that will be available for next time. We can select this. You can of course change, as you have seen, the colors and icons based on attribute values. You can do these rings, the donuts around nodes based on some value. We can add badges. We can size the nodes differently based on some value. See if we have some numerical value here. For example, the degree of a node. So we can decide to style them or make them bigger if they have more connections. I'm going to save this style and leave it there. Of course, the same applies to relationships. We can style them based on their attributes. And the other interesting functionality in the visualization is the ability to group nodes. So let me load a different set of data here, and I'm going to use a global action for that. So So I'm going to just go back to the overview, and I'm going to use a global action that just loads some person connections. So we have a graph here with some people and some Facebook events. Now, people have alias, so they could have different names, but the alias could be the same. Perhaps the name is misspelled, or it comes from different data source, it's completely different, but the alias is the same. So we want to group people by the same alias. Here, there's a grouping tab. We can create a new strategy. Here is one already called by alias. So we're saying if the person has the alias property, same value, we will create a group. So here I'm going to enable this, and we see that here some groups emerged. Here's a group of 3 individuals, all connected to each other. They all have the same alias. We can click on them and see their individual connections, and we can collapse this again and see the connections on the group level. Of course, if we wanted to, we could also take all the remaining nodes and group them together. And here, this poor lady, she has an alias, but it's not similar to anybody else. So we can allow single node groups, and now we have just groups and we can see what's inside. Here's another one, and then the other, that'll be a big group. Perfect. So that was grouping. Let's move on to other kinds of analysis. But before we do that, I want to show you something about virtual attributes. So in many of the visualization tools out there, if you wanted, for example, to change the style of a node based on some attribute, the attribute has to be present on the actual node in the Neo4j database. This is not the case in Hume. We don't have to change our Neo4j database just for visualization's sake. Instead, what we can do is compute the attribute on the fly. Let Hume compute it on the fly. And this is done through a special kind of action. So let's say for each person, we want to have the last seen position and the last seen date. But this data is stored on the actual Facebook events they checked into. So what we want to do is create an action, and I'll show you what it looks like. It's called last seen date for a person, and it has a special scope. It's called computed attribute, which means it will run every time we return any person to the canvas. Hume will automatically run this query, which simply checks for the Facebook event, does some ordering, takes the last one, and sets the last seen date on the person. So if I show you the schema, actually, the last seen date is there. But that doesn't mean it has to be in a database. In fact, it's not in our Neo4j database. So here, if we go back to our visualization, we will see that the people, they have last seen position and last seen date. These come from the computed attributes, special kinds of action. So now that we have timestamps on people and that we have some coordinates, geospatial coordinates on people, maybe we can delete all the Facebook events. So I'm going to select all the same ones and delete it. We'll just be left with a bunch of people to start with and some connections. And we can turn on other kinds of analysis. One of them is temporal. So we can enable this time bar. So if there's a temporal attribute on a node or on a relationship, we can now analyze the graph based on time. So here I can filter and things will happen, things will disappear. We can, of course, use it to, for example, replay through the graph and see how it was changing over time, how it was evolving. And we can also, if we select certain things, we will see on the timeline what that looks like in terms of that selection. Let's try again. Yeah, here we go. The other kind of analysis Hume offers is geospatial analysis. So if these have properties that are coordinates, which we know we have, we can enable this kind of analysis. And then the nodes will be plotted on a map with all their styling, with all the actions. So you can still run all the actions as you would. So here I can expand 2 hubs here, and we will get those expanded and again placed on the map. We can also run actions that are contextual to the mouse click. So if I right click here, there's a very simple one just called show cursor coordinates. If I show you, this is just a table, but you can use those in the Cypher query as you're creating the action to simply search around or do other kinds of queries. This is the map view. Of course, it's combined with the time bar. So if we filter, things will be filtered out. We can also bring data onto the map from completely different data source. So it does not have to be the same graph or even the same database. So here we can, for example, load earthquakes into the map. And the interesting thing is that here what we're trying to demonstrate with this functionality is we're loading things within the bounds of the map that we're looking at. So as I'm going to be zooming in, we're issuing queries and we're loading data on demand as the user zooms in into the map. And now this data comes from a completely different database. So that's one of the possibilities as well. Let me turn off the geospatial analysis and the temporal one as well. Good. On the layout, let's look at something else. So let me clear the canvas and show you another feature, which is virtual or computed relationships. On the perspective level, what we can do as users is we can simply define shortcuts. So if an investigation would take multiple hops, for example, let's say I was looking for who this person met through the Facebook check-in event. So I'd have to expand all the checked-in events, and there could be quite many, and I would have to go either one by one or kind of select them all somehow and expand that again to see who else checked into this event. And of course, this could be, there could be thousands of them, so this would be quite an involved analysis. So what I can do instead is take some shortcuts. So on the perspective level, I'm going to create a new relationship. It's going to be a virtual one from person to person, and we're going to call that relationship met person. And we can define a path by clicking around the graph. So we have the start node here, and we're going to say this person checked into an event. That's the first step. And then that event was checked into by another person. So we're going to use the same relationship twice, but we could also go around the graph and create even a longer path for our shortcut. We could also use a custom cipher query if we wanted to. So now that I have this path, person checked into event, and that was checked into by another person, I can go back to my visualization and I can look at the same guy. And now when I right click, I will see blue virtual relationships. And if I expand them, we will see that he met two people. We could leave it at that. Or if you're interested, you could say, okay, I want to explain what that is. And you will get the actual path in between the nodes, the one that comprises the virtual relationship. Hume also has the ability to share the results of your investigation. So if you found something interesting, you can take a snapshot, call it my investigation, and we will take a copy of the data as it is. So if the underlying data changes, you can always go back to your snapshot, and you can still run layouts on it and things like that, but you won't be able to expand the nodes anymore because this is a static snapshot of the data. You can share this snapshot with other people by creating a shareable link. If they click on this link, they will come here to this snapshot if they're logged into Hume. Next, I want to talk a bit about search. So I'm going to go back to the actual visualization and say I want to search for something. So here you can just start typing. If I type AZ, I will get some documents, some people, maybe some other things. We could also, because we have a schema, let Hume suggest what we should be searching for. So here I have some autocomplete. I could say person.name is like this, and I will get one of my people here. And then another thing is we could, on the perspective level, actually tweak the relevance of the search based on certain criteria or certain requirements. So if I go back to the visualization again and show you what happens when we search for, let me clear the canvas. We search for AZ, you will see that we get some people. But what if I wanted vehicles? They're somewhere down here, they're not even showing. So, I mean, I could get some vehicles that are with AZ, but they were not marked as the most relevant. So we could go back to a perspective and we could open the search relevance tab and we could say vehicles and specifically their names are more important than people. So we could boost the, it was not the name, it was car model. So we've just put 3 points here and that will boost the search query. So next time we go to the visualization, same one, type the same thing, AZ. This time we get vehicles boosted. So they're the first. So there's a bit of tweaking that can be done here on the search relevance. We talked about features that allow people to not get stuck with too much data on the canvas. I will show you a few more. The first one is you can actually, when you right click on a node, you can configure what happens on the double click. So instead of expanding everything, we could choose to expand specific relationships only, or we could choose to run any action we desire. So in this case, if I choose expand to hops, then by double clicking on this node, I'll get immediately the expansion to 2 hops. The other feature, which is quite handy, although it's quite basic, is the undo. So if you get stuck, if you have too much data, you just go back. The last feature I want to show you is alerting. So this is quite a new feature in Hume, and what it does, it monitors patterns. Specifically, it monitors the emergence or disappearance of patterns. And here we're going to look at a pattern called people connecting to threads. So this is pre-built here already, so we don't have to type it. And it's any person with a given name, so you can parameterize these things. Up to 2 levels relationship of type exchange with a person that is marked thread is a pattern. So we will monitor the emergence and disappearance of this pattern. We will pass in the name of the people we want to monitor, and we will run this query every 30 seconds to check for new results or missing results. So with this pattern in place, the other thing I have to do is create a collection. So here I'm going to create a new one called demo POIs, people of interest, and the perspective is going to be our murder mystery. And so what I can do is I can find some people here. I'm going to find some random people just by clicking on person. And I'm going to make sure, let's see, this one, for example, just by double clicking here, that they're not connected to a thread. This person is indirectly connected to a thread. Let me check another one. This one is not. Brad. And let me try another one, Leslie. Okay, good. So there's 2 people who are not connected to a thread. So what I'm going to do is add Brad to a collection and Leslie as well. So now we've built up our people of interest. We can go back to alerts and we can see our collections. And here's the collection with our 2 people. So what we now can do is define an alert. I'm going to call it demo alert. And we can select the pattern. So we're going to be watching for people connecting to threads. And we know it's going to run every 30 seconds. And the collection we're going to be using to feed the name parameter is our demo POIs. And I'm going to see that it should email me. And the email should be immediate. So we're not going to look at the email, but we're going to see the alert triggering. So what we're going to do is now enable this alert. And when we look at events, I mean, there will be some old events, but that's okay. Nothing here of interest yet. We're going to go back to our visualization and we're going to take the people that we selected. We'll take one of them, for example, this one, and connect to this thread. As a red badge. So I'm going to use an action to connect these 2 with the exchange relationship. Submit. This relationship has been created. We will see maybe this person is connected to some other threads. Yes, so maybe there will be multiple events. Let's see. If I go back to alerts, our events now contain a new alert. I will also get an email. And you can expand this event and explore it and see that the path is from Brad, who was the person of interest, to Rogelio, which is the threat. Now this, of course, is not the best way to display, but in the next release, we will have a graph view here so you can see the actual pattern emerging. That concludes our Hume demo. Hope you enjoyed it. If you have any questions, please get in touch. info@graphaware.com. Thank you.